The sum of the squares of two odd integers cannot possibly be the square of an integer. So I'm going to declare that this is a true statement. But of course, let's prove this. So let's pretend that this can happen. Let's pretend that the sum of the squares of two odds can give you the square of some other integer. Let's pretend this can be true, and then we're going to run into a contradiction. So let's pretend that this is possible. So I'm going to try to take two odd numbers, square them, add them together. So here is an odd number. Let's go with 2m plus 1. This is an odd number, it's going to get squared. Here's another odd number, 2n plus 1. That's going to be squared, and we're going to add these together. So we're going to pretend that the sum of two odd of integers, the sum of the squares of them, they've been squared. The sum, let's pretend that this can equal the square of some integer, call it k. All right, and of course, m, n, and k. So let's just say m, n, and k. All these guys are integers. Now, why don't we take this and square this binomial? If you square it, it's going to be 4m squared plus 4m plus 1. If you square this, it'll be 4n squared plus 4n plus 1. Drop the main addition symbol. All this equals k squared. Let's combine like terms a little bit. This will be 4m squared plus 4m plus 4n squared plus 4n. I'm going to combine the 1 and 1 to give us a 2. I'll leave the k squared alone. Now what I want to do from here is, let me take out a 2 from here. Here's what I want you to see. 2 times blah, blah, blah equals k squared. You know what that means? That means that 2 can divide k squared. Here are two cases. K is a number. It is an integer. It has two possibilities. K can be odd or it cannot be odd, making it even. Those are the only two options. I can tell you K cannot be odd. Because think about it like this. Let's pretend, let me just make this up and then I'll scratch this off the paper. Let's pretend that K is 5. If you plug in 5 for K here, it's going to be 25. Can 25 be divided by 2? No, 2 cannot go evenly into 25. What if K is like 7? 7 squared is 49. Can 2 divide into 49? No, because 2 can't go into either of these numbers, much less the square of these numbers. So for that reason, you can tell them this. So where K is odd, case 1 K is odd, you can say this is not possible. This is not possible since 2 divides k squared. That implies that 2 divides k. And if 2 divides k, then k is even. The only possibility now is that k is even. But I want to show you that even that is not possible. Now, since 2 divides k, comma, then that means that 4 should divide the square of k. And that's what that means. Like, for instance, if 2 divides k, think of an even number. 2 divides like 4. If I square 2, that means 4 divides the square of that, which is 16. Here's another example. 2 divides, let's say, 18. And that means that the square of 2, which is 4, is going to divide the square of 18, which is 324, and so on and so forth. That's true. So if 2 divides a number, then the square of 2 divides the square of that number. But I want you to see that this is also not true because, look, who is k squared? I'll even circle it. I want you to pay attention right here. K squared is this. They're saying that because 2 divides k, which it clearly does, then 4 has to divide k squared, which means k squared can be divided by 4. But nuh-uh, because look, k squared is this. Is all of this divisible by 4? Nope, because this is divisible by 4, and so is this and this and this. But this one is not. This cannot be divided by 4. So that piece alone ruins this whole thing. So K is not odd, but it's also not even because this here doesn't happen. And so because K is not odd and K is not even, K does not exist, which is why they say that this cannot happen, which means that this statement is true. So this was just my thoughts on paper. It was very, very scatterbrained. You want to, of course, try to write this down in a more formal fashion.